why do you think I drew the model that I did here? Discuss with an elbow partner why you think I drew the model that I drew here. I'll give you about a minute to discuss that. So one possible answer could be that when you look at 15 times 13, you're seeing 15 as 10 plus 5, and you're seeing 13 as 10 plus 3, and those two things are being multiplied together. So 15 times 13 is equal to 10 plus 5 times 10 plus 3. So when you're seeing this rectangular array, it reminds us of the story of units, where they use the area models for multi-digit numbers to teach multiplication algorithms for understanding. It clarifies the use of the distributive property to generate and record either 2 or 4 partial products when multiplying two-digit numbers. So let's go ahead and complete the rest of our area model here. So at your tables, go ahead and complete the rest of this area model here. So let's go ahead and finish it up together up here. So now we have 10 times 10. So this area of this portion is 100. 5 times our 10 here gives us 50. 10 times our 3 is 30. 5 times 3 is 15. So we have a total area here of 100 plus 50 plus 30 plus 15, which is equal to 195. So 15 times 13 is equal to 195. So work with these concrete numbers from a story of units provides the foundation students need to do the more complex work that we get in a story of functions, such as with multiplying polynomials. In the next examples, we're going to use tabular models, which will be used the same way as our rectangular array. In later grades, we refer to this model as tabular method because negative values are not accurately depicted by length, which is represented with that rectangular array. So let's look at our next example, which is B. So we're going to multiply x plus 5 times x plus 3. So here now we have two polynomials, more specifically two binomials, x plus 5 times x plus 3. So again, we said we were going to start off with a similar model. So we have that rectangular model, but we said we were going to call it a tabular model now. So we want to go ahead and separate it. Since we have two binomials, we're going to go ahead and separate it similarly to what we did before into two parts this way, and again 2 parts this way. So let's take this first piece, x plus 5, and let's go ahead and call this first part the x, and then this next piece we'll call it 5. And then vertically here, similarly we'll do the same thing with the x plus 3. This part will be our x, and here will be 3. Okay? So let's see if we can finish the rest of this model. So same thing that we were doing before. We will find like the area of each piece of it. We will do that multiplication. So go ahead and do that at your tables. I'll give you a minute to be able to complete that model. Okay, so x times x gives us x squared. 5 times x gives us 5x. X times 3 gives us 3x. Then 5 times 3 gives us 15. So what we're going to do next here now is let's take and look at this diagonally. So here we have x squared. And along this diagonal we have 5x and 3x. So together we have 8x, because they're similar terms, they're like terms. Then we have 15 here. Okay? So we have x squared and 8x and 15. So x plus 5 times x plus 3 equals x squared plus 8x plus 15. So how does this model compare to the model that we just had with our multiplication? What coherence do you notice from part A to part B? So here's some of you saying, the only difference, or one of the differences you see, is that in this model we have variables. We didn't have variables in the first model. Right, that is so true. So this is what we're going to see as we progress to the later grades. The other thing is, someone noticed that if you have an x here, if you take that x and replace it with 10, and you completed the rest of it, and you replace this x with a 10, and you substituted and completed it, evaluate that expression, you would get 195, which is the exact same answer you had before. Very good. Now, our next example, C, we're going to take this same model, but instead of doing this piece, we're going to undo. We're going to take a trinomial, and we are going to factor that trinomial into two binomials. So let's look at that third example. Example C. So our example here is x squared plus 2x minus 15. Now we said already we were going to go ahead and do a factor this into two binomials. So when we're using the same method, we're using that tabular method. So we need that rectangular model, that rectangle to start with. And since again we're looking at two binomials, we're going to go ahead and separate it as best we can into 4 parts, trying to get this one to be as close to the same as we can possible. Now we can't put the two pieces on the top here because we don't know what those pieces are just yet, but that's what we're going to be looking for. However, we do know that this piece over here going this way is an x squared. These two pieces together add up to a 2x. And this piece here adds up to a negative 15. So what can we fill in any of these pieces here, these partial products? So let's see. X squared. The only box that's going to be an x squared is this big square here, this big rectangle here, which happens to be a square. So that's my x squared here. And I'm not sure about this one and this one because these two on that diagonal add up to be this 2x. But in this negative 15, this is the only box that's going to be like terms with that. So that's going to be a negative 15 here. So at your tables, I want you to figure out, what do I need here to figure out how to get that 2x? So that's what we're going to determine. So take a minute to figure that part out. Okay? Okay? So I saw some of you notice that 15 has factors of 3 and 5. So if I'm looking for a 2x, we're looking for a 3x and a 5x. Well, maybe since it's a negative 15, one of them could be a negative 3 or a negative 5. So we'll just happen to set negative 3x and a 5x give us that. So if I'm looking here, I can say, well, this could be a 5x here, and this could be my negative 3x here. Okay? So 5x and negative 3x gives me positive 2x. Okay, very good. So in that case, Let's see, what are my numbers that go in these pieces? What goes in these blanks? What gives me an x squared? Well, x times my x gives me this x squared. How do I get my 5x? X times 5, so a 5 goes here. What number goes here? X times what number gives me negative 3x? That gives me a negative 3. Then what number goes, oops, I got all my numbers in here, so we have our factored form here. So we have x squared plus 2x minus 15 equals my factored form of x plus 5 times x minus 3. And we have taken our trinomial and factored it into our two binomials. And we're done. Thank you.